And he's chasing down the next target. He's switched because this one was closer. As you can see, Figure's making his best bet to his best effort to get away there, but he can escape our knight. And you can see that the pathfinding is pretty smooth here. Hello everybody, Yellow Mustang here again with another Roblox scripting tutorial. Today we're going to be making an AI knight guy here that runs around and kills stuff. We're going to implement him with pathfinding. He's going to swing his sword, and we're going to have him chase down these figures and murder them, so that'll be good. Let's look at the actual template we got here. We got an animation script. I pulled the Roblox knight animations and loaded it into this script. I made a sound script custom for this guy. It basically just takes the humanoid events and then just plays the sound according to whatever event is playing. So running, run sound, jumping, jump sound, dive sound. You get the big oof or whatever. And I got all those sounds in the head. R15 body packages today. I pulled the knight package from the catalog. I believe it's like the Artho model. It's like the new age custom mesh thing. Doesn't look like Legos anymore. It's like, I don't know, something else. I welded the helmet to his head in place, so that's all good. We got a sword here that I just welded to his hand, and then it's got the sounds in here for everything. So the lunge, you got slash, and then unsheath. So when he takes it out or puts it away, we'll play that unsheath sound. So that's pretty good. We got two different animations for when he swings the sword, swings it left, swings it right. So it'll give it a little bit of variety in there. So without further ado, let's create the script here. And we will name this script AI as usual. Starting off, we're going to declare our variables here. So main body parts. And then we're going to start off with local myRoot equals script.parent. Wait for child, humanoid root part. And then local myHuman equals script.parent. Wait for child, humanoid. Good. Then we need our right hand. Local right hand equals script.parent. Wait for child, right hand. And then we need upper torso. Yeah, upper torso. Script.parent. Wait for child, upper torso. Okay, so that's all for the body parts. Then we need the weapon variables. So we'll do local sword equals script.parent. Wait for child sword. That's all good. And then we need the weld inside the sword. So we need local sword weld equals sword. Wait for child sword weld. Okay, good. And then we will declare our sound variables. So local lunge sound equals sword, wait for child, lunge. Local slash sound equals sword, wait for child, slash. And then local unsheath sound equals sword, wait for child, unsheath. Okay, good. So there's all our sounds we can call upon nice and easily. And then we need some booleans for the logic that we're gonna set up. So we're gonna have local attack cool equals true. So that's a cooldown for him swinging the sword. And then local sword holstered equals false. So if he has his sword out, then it's going to be false. If he has his sword on his back, then it's going to be true. Then we'll do local chasing equals false. So if he's actively chasing the guy, then that'll be true. Then we need local fail count. Path fail count equals 0. So if the pathfinding fails too many times, then this is going to keep track of that, so we can you know, try to run an unstuck kind of function there. Next thing we need to load is the animation variables. So animation and then local left slash equals script.parent. Wait for child left slash. Okay, good. And then we need to load that into the humanoid. So local left slash animation equals my human, load animation left slash, good, and then set the priority, left slash animation dot priority equals animation, oops, sorry there, anim dot animation priority dot action. So that's the highest priority. Then we're gonna do local right slash equals script dot parent, wait for child right slash, then same thing again, local right slash animation equals my human, load animation right slash, good, and then set the priority again, so right slash animation dot priority equals nm dot animation priority action. Okay, so that'll take that'll override the default walking animation, so we can just play that while he's running towards the target. The next variable we're gonna need is the respawn variable, which is just a clone of him. So we'll do local clone equals script.parent clone. So when he dies, we can go ahead and just set this clone to set the parent to workspace, and then we'll have a fresh new guy once this guy dies. So that'll be good. Let's lift this up a little bit here. Okay, so the first function we're going to start off here with is the get unstuck function. So we're going to run this if the pathfinding fails too many times. Then this is just going to be a quick little cheat to get our guy unstuck, basically. So vector3.new, math.random, -1, 1, 0, math.random, -1, 1. Okay, so that should be good. And actually, it's not move to, it's a move. So this is going to have a move in a random direction, essentially, and just keep walking until the human is told to go somewhere else. So that's the difference between move and move to, is this takes a direction, whereas move to takes a position you're moving towards. Okay. So then we're going to do the wait 0.3 in there, and this function is done. So let's move on. Next function we're going to be doing is the wander function. So when he has no targets, we're going to have him wander around. We'll do local xrand equals math.random -50, 50, local zrand equals math.random -50, 50. Okay, good. And then local goal equals my root dot position plus vector3.new xrand 0 for the y, zrand. Okay, so that's going to generate us a new goal position to walk towards based off of where we're standing. So then we'll do our pathfinding variable. So local path equals game get service, pathfinding service. Then we'll create path. Okay, and then we got to compute the path. So path compute async. Starting position is going to be my root down position. Ending position will be goal. Okay. So now we will check if the path is successful. So do path.status equal to nm.pathStatus.success. Then we will continue, and then we could put an else in here, and we'll just say path failed. We'll answer that later. So after we succeed, then we're going to set that path fail count to 0. And then we're going to get the waypoints. So waypoints equals path get waypoints. This gives us an array of points to walk towards, and we'll just loop through each one. So for IV and I pairs, waypoints do. Okay, so this is going to iterate through all our waypoints that we have, and then we'll do if v.action equal to nm.path waypoint action dot jump, then have our character jump. So we'll do my human dot jump equals true, and then we will tell the human to move to the V position. Okay, so that should be good. And then we'll put a check in here after we start moving. We'll check every time the iteration is divisible by 5, then we will run this check. So we'll do if find target, then break. So we're going to create this function here in a few minutes, but essentially if we can find a valid target to move towards, then break out of the wander function, and we're going to start chasing whatever target we can find. Okay, so let's continue here. So after that, we'll do local move success equals my human dot move to finished, wait. And then, so that's going to pause this script here until our humanoid finishes moving to wherever it's walking to. And we assign it to this variable because this will return if it made it to that position successfully or not. So we'll do if not move success. So if it didn't make it successfully, then we are going to just break. We're going to break out of here because the path is invalid, and we're going to generate a new path because potentially we could be stuck. Okay. Now we're going to jump down here to this else statement here. And we're going to put in the logic for if the path fails. So we'll do that path fail count equals path fail count plus 1. And then we will do if path fail count is greater than 10. Then we will set the path fail count back to 0. And we'll run our get unstuck function there. So you see how that kind of works there. If this generates a bunch of failed paths, then we're probably in an invalid spot. So we will walk a random direction to try and attempt to get to a valid spot where we can actually pathfind from. So that's a simple way of doing that. Let's go ahead and move on to the next function here, which is the find target function that we have sitting up here. So let's go ahead and bust that out. So function find target. This is going to search for valid targets within the workspace for us to get. So we'll do a distance of 200 for our range, 200 studs from our character there, and then we will set this placeholder as nil for the target, and then we will go ahead and loop through the workspace. So we'll do ipairs workspace get children do, and then we'll do local human equals v find first child humanoid. So we're looking for a humanoid in whatever part we're on. Then local torso equals v find first child torso. If we can't find a torso, we will also accept a humanoid root part. So find first child humanoid root part. So this will work with older models and newer models because it'll find either or and assign it to this torso variable. So that'll be good. Then we will check, so we'll do if human, and so if the human exists in that v that we're searching through, and torso exists, and v.name is not equal to script.parent.name, then we will continue. So basically, if we have any other knights in the workspace, then we will ignore them because they'll have the same name as us. So next check we'll do is we'll check the distance. So we'll do my root position minus the target, not target, the torso position. And then we'll get the magnitude of that, so the difference. And then if it's less than our distance, then that'll be good. So essentially we're checking if their torso is within 200 studs of our torso with that. And then we want to check if the human health is greater than 0. So we only want to be searching for alive objects there. So then we'll set the target to torso, and then we're going to update the distance. So the next target will have to be closer than this one. So as we go through, we will eventually get to the closest target, essentially. So that updates that, and that'll loop through the whole workspace, and then we'll wind up with a target that is closest to us if there is one. And then down here, we'll just return target. So that's all good there. Okay, so the next thing we're going to do is a function check site target. So when we call this function, we're going to be passing basically the torso of whatever target we're on. So just keep that in mind when we refer to target here. Is actually just somebody's torso. So check site is actually pretty simple. It's just ray casting to see if we can if we have a direct line of sight to whatever we are chasing. So we'll do ray.new. Starting position is my root position. If I could spell. Okay, and then we want to put the direction in here. So it'll be target dot position minus my root dot position dot unit. So that gives us the direction, and then we will search 200 studs in that direction. So the ray will be 200 studs long in this case. So then we'll call upon the ray here. We'll do local hit position equals workspace find part on ray with ignore list, put in our ray, and then the ignore list will be script.parent. So ignore all of our body parts when we're doing the ray from the root part there, so we don't hit our arms or something. The next thing we're going to do here is check if we hit something. So if we did hit something, then check if hit is descendant of target.parent. So if we hit the target's leg or arm, it'll still be valid. We still have a good enough line of sight that we can start running towards it. So, and then if we can hit one of those body parts, then we will return true there. If we don't hit anything, or we don't hit the valid parent there, then we will return false. So yeah, so the whole function of this is just checking to see if we have a direct line of sight towards whatever we are, target that we're moving towards. Then we're gonna create a function called check height target. Okay, good. So again, target will be a torso. So we're just gonna do a simple math.abs my root dot position dot y minus target dot position dot y is less than 3, then return true, and if not, return false. So that'll be good. So all this math.abs is doing is it's going to find the difference between these two numbers here and then turn it positive, basically. So that'll give us the difference between the height, whether it's too high or too low. We want it within 3 studs of how tall our torso is. So the next function we're going to create here is the actual path to target function. So we'll do function path to target, and then have the target in there also. So we will do our pathfinding variable, so local path equals game, get service, pathfinding service as usual, create path. Good. And then we will compute the path, compute async. Starting position will be our root position. Ending position will be the target position. Okay, good. And then we will do if path.status equal to enum.pathStatus.success. Then continue. And then we would do the else in there. Just put path fail for now. We'll come back to it after we're done writing this other stuff. So then we'll set the path fail count to 0 again, just in case we failed some paths in the past. Just in case we had some failed paths in the past, we will reset that back to 0. And then we will get the waypoints as usual. So local waypoints equals path get waypoints. Okay, good. And then we'll go ahead and loop through those waypoints as usual using ipairs. So waypoints do, and then we'll do if v.action equals to enum.path path waypoint action dot jump, then myHuman.jump equals true. Okay, good. So jump if we need to. Next thing we're gonna do in here is call upon a spawn function here. So we're gonna run this basically in a separate script. So spawn function, get the end in there. Okay, good. And then we'll wait 0.5 seconds in here, and then we'll do if my root position dot y is less than my human dot walk to point dot y, and chasing equals to false, then my human dot jump equals true. So essentially this is going to make sure when we're walking to each waypoint we jump if we need to. Without this, sometimes the pathfinding service, even though we have this in here, won't tell the AI to jump. This is just double checks it half a second later to retell it to jump, so that makes sure we don't get stuck on stairs or something, or like the side of a cliff. So that'll be good. So now we will tell my human to actually move to the point. So move to. b.position being our waypoint. So we'll just move straight to the waypoint. And then we'll do local move success equals my human dot move to finished wait. And then we'll do if not move success, then we will break. We will break the path and probably generate a new path, because if we couldn't get to the waypoint, then the path is invalid. We are stuck. Okay, so then down here, once we move to the point, we will run some checks. So we'll do if the iteration is divisible by 5. So every 5th waypoint, we are going to do some checks. So we're not constantly doing this check every waypoint. We'll wait a couple of waypoints before we do this check. So we'll do if checked, check direct. Yeah, so we do need one more function created before we actually do this. So let's run up here. We'll create one more check in here. We'll create a function check direct target. This is essentially going to be a function to see if we can start running directly at the target without using pathfinding. So we'll use check site target. So if we can see the target, check height target. If the target is within a couple studs of the same height as our torso, then that'll be good. And then we want to check my root dot position minus target dot position dot magnitude is less than 30. So if we're within 30 studs of the target, then that'll return true, and we will continue. So, and then overall, we will return true from this. And if we don't return true, then we'll return false. Okay, so let's continue with the path to target function here. So we'll do if check direct target, then continue. And if we can run directly at the target, then we're just going to break out of this pathfinding here, and we'll just tell the humanoid to run directly towards the target. And then we'll do another if statement in here, and we'll do if target is not equal to find target, then break. So if there is a better target that's closer to us, then this will also break out of the pathfinding, and we will generate a new path to a new target, essentially. Okay, and so after that, out here, we will do if waypoints. So if the last waypoint dot position minus target dot position dot magnitude is greater than 30, then break. What did I do wrong here? I think this goes up one end. Yeah, it's up here. Okay, there we go. So we will check if the target moves away from our final endpoint by 30 studs, then we'll go ahead and break out of this and generate a new path, because there's no point in walking towards, where the target was. We want to walk towards where the target currently is. Okay, so now we can go ahead and fill in this else statement here. We will go ahead and tick up our fail counter equals path fail count plus 1. So every time we fail, increment that by 1 and check the total count. If it's greater than 10, continue, and we'll reset the counter back to 0. And then we will run the get unstuck function again. Okay, so that's all there is to the path to target function. Let's continue on here. Now we will create the chase function. So do function chase target. And we'll do, we're going to have our human run towards the target if we're that close. So we'll do walk speed equals 20. So it's a bit faster than the 16 that we're normally walking. And then we'll set the chasing value to true. And then we'll have my human move to target position. We don't need pathfinding in this case because we did all our checks. And if this function is called, then we're going to ensure that we have a direct line of sight and we can just run straight there towards the target. Okay, so let's go ahead and create the main function here so we can tie all this logic together. And then below that, we will create our while loop there, and then we'll just keep calling the main function. So in the main, we want to set the chasing equals false. Okay, and then we want to set our human walk speed to 16. So it basically like resets the character every time we loop through the main function. And then we'll do local target equals find target. So that'll assign the torso of the target to target if we find a valid one. And then so if we have a valid target, then continue here. And then we will create the target distance variable here. So target distance equals myRoute.position minus target.position dot magnitude. Okay, so we use that. So that's just the distance from the target to us in studs. And so we'll check if the target, we will check if direct target, then we will go ahead and just run towards the target. So we'll do if target distance is greater than 3. So we don't want to run, we don't want to like push the target. After we get within 3 studs, then we can stop chasing. So we'll do, go ahead and chase target. So that will tell our knight there just to move directly towards the target if we're close enough. Okay, so that's good. And then out here, we'll put else. So if we don't have a direct line of sight to the target, then we're going to do another check here. So we'll do else if check site target. So if we can see the target, and we'll do math.abs myRoute.position dot x minus target position dot x is less than 1, and math.abs myRoute.position dot z minus target position dot z is less than 1. Then so this is doing a check. If we're standing directly on top of the target, then we're going to get unstuck here, because sometimes the knight would stand on the target's head. So I came up with this. So we'll just run the get unstuck function there. And then else, so if we don't have a direct line of sight to the target, then we will just path to target. So if all this else fails, then last resort, we use pathfinding and path our way to the target. Okay, and then if we have no target though, what did I just do there? Why is that? Why are you going there, buddy? Here, come back here. There we go. So else, if we don't have a target up there, then we will go ahead and just wander. Okay, so call the wander function. Let's go ahead and run this script here and see if we have any errors in it, or if this guy will chase the figures successfully. Okay, so of course I got typos. Always got typos when you're typing that much. So missed an I in there, magnitude. Correct that. Next. Okay, typed it wrong again. I guess I have a huge problem typing magnitude. So magnitude. Don't forget the I, guys. Okay, and there he goes. As you can see, he's running towards the targets. Once he gets in range, then it breaks. So that's great. Let's go ahead and fix this. Call global chase. Okay, I see. And here, this is chasing equals true. Let's go ahead and run this again. As you can see, the knight is running towards the figures there. And once he gets close enough, then you can see his walk speed increases, and he gets within 3 studs of the target and then kind of just stands there. This is so, you know, he doesn't get right on top of him, but he gets close enough where the sword would actually be hitting him. Okay, so the next thing we gotta do here is actually implement the attacking. So let's scroll up here, and then under check direct, we will create another function called attack. And again, with the target in there, we'll do a check. So if attack cool equals to true, and then we'll set it to false. So we don't attack a whole bunch of times. We want a cooldown to it. And then we're going to tell my human move to target.position. So this is going to ensure that our knight is actually facing the target that it's swinging the sword at, so it looks more realistic. Next, we're going to play the swing animations. So we have 2 of them. So we'll just have a random value decide what to do. So do attack anim equals math.random 2. If attack anim equals to 1, then we will play the slash sound. And we will play the left slash animation. Okay. Then we'll do else, and then we'll play the lunge sound. And we'll play the right slash animation. Okay, so that'll play a random sound and slashing, sword swinging motion there. Next thing we're gonna do is actually have the guy take some damage. So do local human equals target dot parent dot humanoid. Okay, and then we'll do human take damage. Math.random, we'll give it a little bit of randomness. Looks good. Minimum 20 damage, maximum 30 per swing. And then we'll do a check here. So if human.health is less than 1, then we killed him. And then we're gonna pause for like 1/3 of a second there and just have our guy enjoy his kill. And then after this, we will have the cooldown thing. So we'll do spawn, put this in a separate script so it doesn't pause our code here. So we'll do function wait 1. So cooldown at 1 for our sword swing. And then after the 1, then we would say attack cool equals to true end. Okay, so that's a simple way of doing a cooldown. So that way it doesn't pause our entire script. We can have our knight still chasing the target while this is cooling down. So that works really well, I've found. Next function we're going to create is the holster sword function. So do function holster sword. Okay, and then we'll do if sword holstered equals to false, then sword holstered equals to true. So we don't want to like keep reholstering our sword if it's already, you know, on our back. So that's a good way of detecting that. Then we will play the unsheath sound. Give it a nice little effect there. Then we need to mess with the weld. So sword weld dot part 1 equals nil. So we'll remove it from our hand is what normally is part 1. And then we need to change the C frame. So we're going to teleport the sword to our back. So sword C frame equals upper torso dot C frame times C frame dot new 0.7 times C frame dot angles math.rad 90 math.rad -45 and math.rad 0. Okay, so I calculated that before the video, and that'll just put the sword on his back effectively and rotate it the correct way. And then we're going to set the sword weld part 1 to the upper torso. So when our upper torso swings back and forth, the sword will look like it's actually attached. So that'll be a nice little effect there. So that's a simple way of holstering it. Next, we will draw the sword. So function draw sword. Okay, and then we're only going to run this if sword is holstered. So if the sword holster is true, then continue. Then we'll do sword holstered equals false. Okay, so that should be good. Again, we'll play the unsheath sound. Good, and then we will do the same thing with the weld. So sword weld dot part 1 equals nil, and then we need to reset the C frame again to teleport it to our hand. So we'll do sword C frame equals right hand dot C frame times C frame dot new, and then 0 0 -2 times C frame dot angles 0 math.rad 180 math.rad 90. Okay, so that's gonna rotate it and put it in our hand properly so it looks good. Then we'll set the weld part 1 to our hand so it actually stays in place as we're running around there. Okay, so that should be good. Let's go ahead and add this logic, those functions to our main function. So let's go ahead and go in here. So if we have a direct line of sight, if we have a direct path to the target, then we'll go ahead and jump into here. Actually, let me sorry, let's go back here. Yeah, so it is right hand, my bad. Went too far back. So in here, if there is a valid target, then we're going to do a check here. So we're going to do if target distance is greater than 30, then holster our sword, else draw sword. So if we're within 30 studs of the target, then we'll go ahead and get ready, have our sword out. If we're further and we got to run for a while, then have the sword holstered, is essentially what that means. Okay, so next in here under the check direct, we'll do if target distance is less than 6. So if we're within 6 studs of our target, then we can go ahead and attack the target. So that should be good. Do a quick check here, make sure I didn't miss anything. Yeah, everything looks good. Let's go ahead and try this out with the knight. Okay. All right. Yeah, you see that amazing amazing holster there, just falls right off. What are we looking at here? Line 146. Yeah, I missed a 1 in there. So sword weld part 1 equals upper torso. Run it again. Okay, as you can see, put it away. And you got close enough. He went ahead and drew it. And you see he uses those different animations. And he's chasing down the next target. He switched because this one was closer. As you can see, Figure's making his best bet to his best effort to get away there, but he can escape our knight. And you can see that the pathfinding is pretty smooth here. Okay, and he jumps and he slashes and he cuts. Very good. Okay, and I guess we got a typo in our wander function there also, so let's go ahead and take a look at that. Okay, there we go. Path.status equals enum.pathStatus. Okay, so that should be good now. One more thing we need to add here above main, I believe. Yeah, above main. So let's go ahead and set up the respawning for this guy if you want respawning. So myhuman.die to connect function. So this will be anonymous. Okay, so when it dies, then we will set our sword can collide equals true. So our sword doesn't fall through the earth when we die, and then we'll wait like 15 seconds, and then we'll go ahead and just like regenerate here. So that clone we had up at the top, we'll set the parent to workspace, and then game get service debris add item script.parent with a 0.1 second delay. So that'll clean up the current body, and then we'll spawn the clone into workspace. That'll be good. In the while loop, we will do a check for our health. So if my human.health is less than 1, then break. So to just break the whole script here, essentially, since we're breaking this while loop when our health is lower than 1. So that should be good there. Let's go ahead and see if the respawning works. See, he's running. Let's go ahead and jump into his humanoid. Set the health to 0. You get that big oof. He's dying. Let's go ahead and fast forward 15 seconds. Okay, as you can see, 15 seconds later, he respawns, puts the sword away, and he's back to chopping up figures. Let's test one more thing with him here before we call the episode. Let's put him over here. Let's change the distance. We'll put this distance at 100. Let's go ahead and run this. I just want to make sure the wandering works. Okay, so I see an issue here with the wandering. If we're going to be wandering, let's scroll up here. So at the beginning of wandering, if we have a successful path, let's check. We'll change the walk speed. My human walk speed equals, I don't know, 10. 10 is a pretty chill walk speed because it looked like he's running. If he doesn't have a target, he shouldn't be running anywhere. And then his sword was still out. So we need in here, we need to add holster sword and then wander. So let's go ahead and run this again with those corrections. Okay. Much slower now. Now he's kind of just taking his sweet time, living life on the edge here. And there you go. I guess our knight decided to commit suicide. That's Roblox's pathfinding AI for you there. I guess he'll come back in like 15 seconds. In the meantime, let's bring one of those figures over here. We'll see. Okay. So as you can see, he transitions perfectly from wandering to attacking. Let's go ahead and set this distance here back to 200. I like 200. It's a good zone. And you can also see if we put multiple knights in here, then they don't care about each other. But if we add another one and we name this one like, I don't know, Evil Knight, just a little further away, then he's got a different name, so he'll be a valid target. And as you can see, these guys are going to rip his face off eventually. Yeah, there we go. And I guess they found another target there. So while these guys go to murder something else, I think this concludes the night tutorial. I would like to thank you guys for watching. Please like and subscribe if you haven't already. If you have an idea for an NPC you would like to see made, then drop it in the comments below and I may decide to make it. That's all I got for today. I'd like to thank you guys for watching, and I'll see you next time.